Now, I always get asked, well, what if the restriction is that it has to be greater than 10 and less than 6? So if I had something like x minus 10 and 6 minus x, then there's no possibility. No value of x will be greater than 10 and less than 6 at the same time, which means that it's just mathematically impossible. That equation just would not work. All right, now we're going to take a look at solving the equation graphically. So anytime that I am doing this, the first thing I should do is state the values where x is defined. And in this case, based on here, it's going to be x has to be greater than or equal to -1. Makes sense? Explain how to use the graphing calculator to find the solution to the equation by using intersect feature on the calculator. I'm going to say y1 is equal to the left side of the equation. I'm going to say y2 is equal to the right side of the equation. And then I'm going to use the intersect to solve for x when the lines cross. So I'm going to go ahead and put into my calculator y1 is equal to root x plus 1. I'm going to graph out where those points would be. I'm going to graph in y2 is equal to right side of the equation. Or y2 equals 4. And if I had done a better job of drawing this, then I can do that intersect feature and solve that they intersect at 15 and 4. Remembering that this is an equation in one variable only using x, so the solution is only the x value. X is equal to 15. When I need to verify, I just sub back in for the variable and show that the left side of my equation equals my right side. So I'm going to say that the square root of bracket 15 plus 1 is equal to 4. That's the square root of 16. Square root of 16 is 4. And the left side equals the right side. So I know that it works. If I'm doing this algebraically, then step 1, even though it says step 1 is square both sides here, and we're going to see it later, step 1 should always be isolate the radical. They didn't state it here because they've already done it for us, but this is where 99% of the people who mess up. Radical needs to be by itself. Great, it's by itself. Then I'm going to square both sides of the equation. Well, same as what we did in the previous stuff, we know that the square root of x times the square root of x is equal to x, which logically means the square root of x plus 1 times the square root of x plus 1 is just equal to x plus 1. So when I square both sides of the equation, then I'm going to square the x plus 1, or root x plus 1, and square the 4, and I'm going to say that x plus 1 is equal to 16. Then I'm going to get x by itself. X is equal to, when I subtract 1 from both sides, 15. And then like we did on the last page, we're going to verify the solution by showing that if I take the square root of 15 plus 1 equals 4, the square root of 16 is equal to 4, 4 is equal to 4, and the left side is equal to my right side. The verification is essential. If you only do the first part and don't verify, your answer could be wrong, even if you did everything else correctly. And we're going to see why that is very soon. If it is asking us to do a more complex one, the process is still the same. Start by isolating the radical. So they just move that 3 to their side and you get an x minus 3. At this point, I always, before I square, put brackets around the right-hand side. And remember that x minus 3 squared is actually x minus 3 times x minus 3, and it needs to get FOILed out. Here is the second most common mistake that happens, is when they say they're squaring the right side, x minus 3, they just get x squared plus 9 or x squared minus 9, which is wrong. That is not what it equals. So when I square both sides, this is still just going to become x minus 1. But this side is going to be x minus 3 times x minus 3 is x squared minus 6x plus 9, or x squared minus 3x plus 9 when you FOIL it out properly. Then I need to move everything to one side of the equation because I have a quadratic, and I need to solve it like I would any of my quadratics. So I'm going to move everything to one side of the equation. 0 is equal to x squared minus 7x plus 10. I can factor this down to factors of -7 that add up to 10 are going to be, factors of 10 that add up to -7 are going to be x minus 2 and x minus 5. And from the first factor, x minus 2, I get a possible solution of 2. And from the second factor, x minus 5, I get the solution of 5, just like what we had with our quadratics. Now, I need to prove that they both work. So, I'm going to take my first solution, and I'm going to say that 3 plus the square root of 2 minus 1 is equal to 2. You have to do the equation as it originally existed and then prove the left side is equal to the right side. 3 plus the square root of 2 minus 1 is going to give me 1. 3 plus 1 is all equal to 2, is equal to 2. 4 is not equal to 2, and that's not a solution that works. But you did all the processes right, and you got that 2. Sorry, still doesn't work. And frequently you'll find that in radical equations, when you square it to get the solutions, you're going to wind up with one that doesn't work. What about the other possibility? Well, if I take 3 plus the square root of 5 minus 1 equals 2. Or sorry, equals 5, not 2. 3 plus the square root of 4 equals 5, 3 plus 2 equals 5, 5 equals 5, and 5 is the correct solution here.